For a stress element with 14 ksi for sigma x, 4 ksi for sigma y, and 12 ksi for tau xy, we want to find the principal stresses and the maximum shearing stress. This is the first example for the main video about the Mohr circle review, link below, so make sure you've watched that before you watch this. We know that the center of our Mohr circle will be found for the x-axis values corresponding to the average stress. When drawing a Mohr circle, we don't draw the full Cartesian plane from the beginning, since we don't know how big the circle is going to be. However, we know that its center is located on the x-axis, so we can draw the x-axis and a circle. The center will be equal to the average stress. The maximum shearing stress will be equal to the radius of our circle, which we have derived an expression for. With the value for the radius, we know that the maximum stress will be 9 plus 13, and the lowest stress will be 9 minus 13. Knowing where the 0 would be, we can now draw the y-axis, or the axis for the shearing stress. Our original stress state for x was located at a sigma of 14 and a tau of 12 that tried to rotate the element counterclockwise. And our original stress for y was found at a positive 4 for sigma and the shearing stress of 12 that wanted to rotate our stress element clockwise. The answer to our questions would be 13 ksi for the maximum shearing stress and minus 4 and 22 ksi for the principal stresses. But let's also calculate the angle theta p and draw our rotated stress element for both the principal stresses and the maximum shearing stress. For x to become our principal stress of 22 ksi, our stress state diagonal would have to rotate 67.4 degrees counterclockwise, which means that in the real world, our stress element needs to rotate 33.7 degrees counterclockwise for the new sigma x to be 22 ksi. The sigma y corresponding to that stress element would be minus 4, and of course the shearing stress would be 0. The angle of rotation so that x becomes the maximum shearing stress would be the complementary angle to 67.4 and in the clockwise orientation. The new values for sigma x and sigma y would both be positive 9, and the shearing stress would be 13, a vector that would make rotate the stress element counterclockwise for the face of x, and a vector that would try to rotate the stress element clockwise for the face of y. If you want to watch a second example for the Mohr circle review video, check out the link in the description below. Thanks for watching.